Sorry, units?
Radians per second.
All right. So I have my equation there for the voltages already. The voltages are going to be 169.71 volts. Cosine of, I'm going to run out of room. So 15 ohms and 200 microfarads. I think that's what I had written down. So equals, and then this was 376.99 radians per second time plus 5/6. Or if you want to go ahead and do the math there, we can put down a decimal. We have to at some point. So we can now at least figure out the voltage. Now, please bear in mind, when we do the cosine here, this will be in radians. So please make sure you are in radians. So at 0.02 seconds, so the voltage at 0.02 seconds is, well, the math is 169.71 times the cosine of 376.99 times 0.02 plus 5/6. And what do we get? So at some point, all right, one person did it.
I got negative 35.28.
Negative 35.28. Anyone else get the same thing? The biggest issue you might run into is if you want radians first degrees. So,
I did check that I was in radians.
okay. He had negative 35.28. Ah, we got two people with that. So you made within sin stream, or is correct. We have three, we're up to three. Can we get a majority?
I got that too.
All right, there we go. Let's assume that that the majority is right. Units?
Volts?
Yep. What is that angle? This angle right here, what is it? If you multiply it out, don't take the cosine, just what'd you get? 8.063. And what is that in degrees? So it's gone all the way around, it's back, okay. So in degrees, I assume it's a second quadrant angle. Try to wrap it first. Did you put it in degrees? You have to look at me if someone who did it.
Yeah, I put it in degrees, but it didn't convert it.
Oh,
Yeah, I got the same number too.
you got that number?
Yeah.
Did you guys just change your calculator to degree mode?
Yeah.
Oh, yeah, to convert, you would that's in radians, so you multiply by 180 over pi.
180 over pi. Thank you. Four.
461.
Yep.
461.999.
461.999 degrees. Minus 360 gives us,
Second quadrant is 101.99.
you know, I'm just gonna be so bold as to say 102.
Thank you.
I know it's imprecise and it's gonna bother some of you, but in your notes, just keep it up, however many decimal places you want. All right, so 102 degrees. So this, because again, these arrows here are spinning around 60 times a second. So at 0.02 seconds, it's gone all the way around, and it's now, so this arrow right here is now here. Everything shifts with it. So when we figure out the angle for I sub c, I'm expecting I sub c to be down here. All right, so let's come up with a couple other things here. We have that information. I need to find current. I know that the magnitude of the current from the resistor is going to be the voltage, magnitude of the voltage from the resistor divided by the resistance. Well, the magnitude is 169.71 divided by 15. We're gonna just amplitudes here. I said magnitude, amplitude is a better word. Units? So my current equation for the resistor is going to be 11.314 amperes times the cosine of, it's going to have the same frequency, angular frequency. So 376.99 radians per second next time. Plus, and now the phase shift. I know that the current phasor is completely in sync with the voltage phasor. They're in phase, therefore it would still be pi over 6. Which is 0.5 something. So the current at 0.02 seconds is, and now it's plug and chug exercise. Negative 2.25. 35. Units? It's current. The units are coming from the amplitude right here, which is amperes. This cosine bit, that's unitless. Now, I knew that the answer would be negative. How?
Because of the quadrant.
Yeah. All right, so we now have, so at t is equal to 2 seconds, this was negative 35.28 volts. This current right here is just a 2.35, negative 2.35 amperes. We now have to figure out the next one, so I'll pop off the screen. current from the capacitor is going to be the maximum current across the capacitor, cosine of omega t plus phi sub c. It won't have the same phase shift as the other ones, because if you look at it, I sub c is 90 degrees or pi over 2 ahead of it. I sub c, I know, is going to be v sub c over x sub c, cosine of omega t plus phi sub c. And so we have v sub c, which we established to be 169.71, divided by x sub c, which is 1 over omega c, 1 over 376.99 times. All right, I'm going to put in intermediate stuff here because this is going to look like a mess.
I have a question.
Yes.
Why is V sub C 169.71 when we have VR equals VC equals V power supply negative 35.2? Is that, oh, that's because it's at 2
Yeah,
seconds?
that's specifically at 0.02 seconds. That's the
in
equation.
beginning. Okay, initial, okay.
Yeah.
Okay. Sorry about that.
Nope, no problem. So this is VC over 1 over omega c times the cosine of that, which equals omega c VC cosine omega t plus phi c. So 376.99 times 2 times 10 to the times 10 to the negative fourth times VC, which is 169.71 times the cosine of omega, which is 376.99 t plus phi. From our phasor diagram, I've already figured out, I know it was given that the phase shift of the voltage phasor is pi over 6. I know that the current phasor for the capacitor is pi over 2 ahead of it, 90 degrees ahead of it. So the phase shift for the current vector is just going to be, this is the phase shift for the voltage plus 90 degrees. Someone would be kind enough to do that.
Isn't it 2 pi over 3?
Okay. Which is, okay, just leave it like that. So what is the amplitude of the current, capacitive current phasor?
Just the amplitude.
Just the amplitude.
Just the amplitude is
80.
throughout. Oh, units.
So, amperes?
Yeah, it's current.
It's just current.
Amperes. Times the cosine of 376.99 radians per second times time plus 2 pi over 3. There's my equation for the current phasor, or for the current across the capacitor. And so now the current across the capacitor at 0.02 seconds equals
Negative 12.52.
Negative 12.52.
52.
That's what I got.
Okay. And it makes some sense. Because I know at 0.02 seconds, my voltage phasor is here. Everything's been basically shifted that way. So at that moment, at 0.02 seconds, my current phasor for the capacitor is down here in the third quadrant. The actual value at a specific time is going to be projection onto the x-axis. So I would expect it to be negative, and I expect it to be close to the horizontal here. So close to that maximum negative value. So, right here's. Negative 12.52 amperes. Now I want to go through finding the current for the power supply using basically the same technique, and then we'll check. It is also possible to find the current from the power supply by just adding those two up. However, let's do it the longer way, and then we can check our answer. Questions before I go to the next screen? Or slide, whatever the appropriate word is. All right, so current from the power supply is going to be the amplitude of the current from the power supply times the cosine of omega t plus phi power supply. Current from the power supply, I know, is the voltage from the power supply over the impedance. And we have a formula right there for the impedance. I know that Z equals 1 over the square root of 1 over 15 squared plus omega c, so plus 376.99 times 2 times 10 to the negative 4th. That quantity squared. Yes?
Can you explain again why, I know it, like our impedance that we found yesterday was not 1 over the square root of 1 over.
Right.
Because that was for RC series circuits only.
Correct.
So why, this is a RC parallel.
Right.
So for every single, so if you have one that is a combination of parallel and series, do you use like one part of it and another, or?
We'll get to it.
Oh, that makes sense, thank you.
Yeah, and again, going along with what Laura said, the formula for impedance is circuit specific. Unlike the capacitive inductive reactance, which are going to be those formulas,
I guess what my question is, really is, does that mean that we need to solve for Z like this before moving, like derive for Z first? If we aren't.
yeah, typically I would say, what's the
It's
formula
like
for
the
impedance?
best bet, okay.
That type of thing. And I do recognize this physics 151. I tortured the 152. I tortured the 252 students. My problems are not intended to torture you. Well, I might torture you in class, but no, I have so far not tortured students on the test with a problem that basically takes an hour. Okay, so what is the impedance?
I got 9.96.
Units?
Ohm?
So my amplitude of my current coming out of the power supply is the amplitude of the voltage coming out of the power supply, which is 169.71 divided by 9.96.
Seventeen point oh four.
04.
Yeah. Amperes. Amperes.
All right, so we have the amplitude now. Omega we found out early on. The phase shift. This is the part that's a little bit different because I can't just add up 90 or anything like that to it. It's somewhere in between pi over 6 and 2 pi over 3. Not exactly halfway in between, despite how I might have drawn it. So we have to figure out what that angle is right there. And then we'll add that to pi over 6. This is a pi over 6 phase shift, and so I need to figure out how far ahead is it from that. So what I'm gonna do is take a space over here. This is IES. This right here is the length of it represents the magnitude of the current for this I sub R, the amplitude of the current going through the resistor, which we already calculated 2 screens earlier. 11.314. So this is 11.314 amperes, and then this represents the amplitude of the current across the capacitor.